A big hello to all and welcome and assalamu alaikum. So let's get quickly started with ESP8266 video number 3. So far what we have been able to achieve, we have been able to send get commands. Those who have not watched part 1 and part 2, I strictly recommend them to watch part 1 and part 2 before we get started with part 3. So the prerequisite for part 3 is that your part 2 equipments are already attached and part 2 is already working. What we have learned and seen in part 2 is already working. So now what we'll be doing in this video is developing a nice user interface, and we'll be operating all 3 LEDs, or you can attach as many LEDs as you want, or you can attach relay boards or whatever you want. We'll be doing it from the web interface and we'll be preparing a nice web interface for that. And today we'll also try and use the station mode, since we have used access point mode. So we'll not be using access point mode today, and we'll be using station mode. And number 3 is what we have to do is you need to open the serial monitor every time you want to get connected to ESP8266. And we are not going to do that. We are going to let ESP work without the serial monitor, or without even Arduino software being opened. Right, so in that matter, if you want to check whether our ESP is connected to Wi-Fi, what we'll be doing, we'll be attaching LED, and if the LED blinks, we are connected. And while connecting, we can blink the LED, and if it lights on completely, so then it's connected. So let's get started, and let me open Arduino. So this is all what we have been able to do in the previous video. I've deleted what we did in loop because loop is going to be completely different. But yeah, send commands remain same. Alright, it takes the timeout, and it takes debug. Debug means whether you have to print what you are doing on the serial monitor or not. And then we are taking the Mills timeline, and we are adding the timeout timings in we can say milliseconds that we are supplying, and then that will be our timeout, right? So for timeout, refer to previous video. We have been able to explain it. I have explained it in very good manner. So send command remains it remains unchanged, and what remains unchanged is the rest of the things. Only loop is different, debug is true. And what I have been able to do here, green LED is output, red LED is output. Right, and red LED I have attached to pin number 11, and green LED I have attached to pin number 12. And what I can do, I can attach let me tell you, YELLOW, yellow LED to pin number 13. So we'll be controlling 3 LEDs. Let it be LEDs or let them be relay boards. If they are relay boards, then initially what you are going to do, you are going to set all 3 as output. So green LED is output, red LED is output, and yellow LED is output. And what is this ESP on? So this is the LED, right, which is going to tell us whether we are connected. And this LED is going to guide us through without even serial monitor, because we will not be doing it on the serial monitor. Yeah, while developing we'll be debugging, but yeah, so this is the LED which is going to tell us whether we are connected to any interface or not, right? So in that case, we have attached LED ESP on. I have named it ESP on. You can name it anything. Status ESP status, let it be ESP status. ESP status is attached to pin number 4, and that is going to be our output as well. So initially I am turning all 3 off. Right, green LED is low, red LED is low, and ESP status is also low. So in case if you are using relay board, which is low trigger, alright, so you have to set them high, then you know that. So what we have been able to do so far is send commands, right, AT plus RST, and then use the carriage return. And next line, send AT plus CW mode, which is an access point mode. So configure ESP module as a station mode. Alright, so I'll be configuring it for station. And today what I'll do here is AT plus CW mode is equivalent to 1, and the new send command is going to be, I'll call the function send commands, and I will pass certain things right here. And ESP has begun, and ESP and serial we are beginning, because ESP communication is taking place on pin number 2 and pin number 3. We know that we have attached the RX and TX of the ESP8266 to as that of the 2 and 3 pin of the Arduino, right? So remaining things remain same. Whatever we are doing is same as we did in video number 2, but yeah, the difference is here, right? So we are going to use send commands like AT plus CWJAP. Now what we are going to do, we are going to get connected to a specific network. In my case, I'll get connected to a hotspot. So in my case, hotspot is IIIT. So I'll be getting connected with this hotspot. So I will say CWJAP, CWJAP is equivalent to skip the special meaning of this quote here, and I will say IIIT. Triple IT is what I'm going to get connected with, and I am again going to skip the special meaning of the quote right here, alright, because we are using double quotes, so double quotes inside double quotes. What I'm trying to tell the compiler here, hey, please do not take special meaning of this quote, right? So do not enclose it, right? So otherwise this is going to be the opening quote and this is going to be taken as a closing quote, right? So we have to skip the special meaning of the quote. We do that with backslash here, IIT, and close the backslash. And now the third parameter that I am going to pass here is password. So my password is, so let me skip the special meaning of this right here. My password is password at the rate of 1, 2, and password at the rate of 1, 2, 3 is my password, and skip the special meaning of this code as well. Right, and now what we have to do is, after skipping the special meaning of the code, I can say carriage return, that is going to be /r and /n, right? So I hope it is done. Okay, IIT, skip it, skip this, skip the special meaning of this code, and yeah, so far we have been able to do, and I'm going to give it good amount of time. So I'll say 3000 milliseconds to get connected to this network, because today's configuration requires us to get connected with other network. Use it as a station mode. You can still use it as an access point, so it all depends on you. Since I have to show you each and every mode, so we are shifting to mode number 1, which is station mode. You can use access point as well, so there's no problem at all. And debug is going to be debug, whether it's true or whether debug is false, right? And after that, everything remains the same, but the only matter of fact is that if I try and upload it, we will be getting an error, right? So send commands, what is the error? Send command, COMMANDS, maybe I have misspelled it, so let me try and upload again. You never know the time it's going to take to get connected to with IIT or any other interface, so you'll have to hold unless you get connected to that interface. You can see that when I call just a moment, send command is absolutely fine, and we have this status string. Everything is working absolutely fine, so there's no problem at all. So let me just get rid of this string right here and try what is happening. Let me upload the program again. I suppose everything is set and done, and my ESP is also connected. Let me see whether my ESP is communicating and it's lined up to communicate and everything else is working fine. Alright, so it should work fine, so there's no problem. Alright, so everything is working fine. Okay, let me try connecting and disconnecting. Disconnect and connect back. COM3 is not available, so COM9 is available now. So it should be okay now. We are able to see AT plus rest will force the restart. Restart is done. Wi-Fi disconnect, Wi-Fi connected, Wi-Fi got busy, right? So you can see we were not able to get IP because the status was busy. While because we have not been able to get connected to this, we need to hold on. We need to tell the ESP that hold on unless you get connected with this. Alright, so what I'll do for this, I will say while, I'll keep it busy, while ESP.find, you know that find takes the cursor unless you're not finding OK, right? Unless, now because the previous command that you are running is cwjap IIT, you are getting connected with the specific username and password, and now if it's connected it will return OK. If you say that cursor will go to OK, OK will be available only when you are successfully connected to this device, right? So if ESP.find OK means that while you're not finding it, so I'll use not, while you're not finding it, right? So this loop will run unless you are not finding it. And to show the progress right here, what will I do? I will do digital write. I'll digitally write to my ESP status pin. So I'll say I'll write to my ESP status pin as low, as high, and I will delay for 200 milliseconds, and I'll repeat the same. So that means our LED will be blinking. This LED which we have attached to pin number 4 will be blinking unless we get connected to this right here, right? So I'll keep it low so that while ESP is not going to send us OK, that means while, unless you're not able to find OK, you keep on revolving around this loop, right? And while revolving around this loop, while looping through, right, you're not going to get here, right? So because you are going to be here, right, so you will jam yourself here unless you get OK. And the moment while you are trying to get OK from IIT, while you are getting connected to this IIT device, right, which is your access point now, because you're using it as station point here, so you're going to blink your LED high and low, high and low, high and low, that you're blinking. So the moment it returns OK, you're out of the loop, and the rest is going to get executed. The rest is same. You are taking CIFSR. Alright, so what you are doing, enter your Wi-Fi network SSID and password. What is the SSID and password of this device? So you can do that. It's not required. If you want to skip this, you can absolutely skip this right here. Alright, so if you do not want to skip it, you can keep it like it is. Alright. And the third is enable multiple connections. Yeah, we are going to enable multiple connections, and we are going to start server on port number 80. Alright, so is that clear? Okay. So I'm going to delete it, CIFSR, let it be there only, so it's not going to do anything for us. So let me see whether we are getting OK or not now. Let us upload it. Uploading, done. So let me open the serial monitor now and see what are we trying to get. Yeah, reset is OK. Now you can see Wi-Fi. Okay, now you can see this. You are running CWCHAP and it's still disconnected. So unless it returns, you can see the LED will be blinking, right? So now you can see that now you are connected. Then you move to the next line, that is CIFSR. You are going to get your IP address, that is 192.168.137.43, and you have started server on port number 80. So now we are connected. Now imagine that if we are connected to an internet router, or your mobile already has internet, now we can say the ESP device is connected to internet. Now we can port forward and call it from any other location using internet, right? So far this is done, and nothing else is required here. What I want here to be, so I'll say digital write my ESP status to high. So that means now if my ESP status LED glows, which is attached to pin number 4, so I will, without even checking the serial monitor, I'll come to know that ESP8266 device is connected to my access point or my internet. So right, so that is the way that you are going to know whether you're connected. So now let us see. Yeah, now LED has light up. Now LED is on, it's set to high, that means we are good to go, we are connected, right? So now everything that we have to do is to be inside this loop. But I want to send a web page now. Now imagine I want to send a web page. Earlier we were trying to send get commands from here. I'll show you from this area. Okay, let me copy this. I tried it earlier, so let me copy it here. Okay, 192.168.137.43. What we are trying to do, we are sending option is equal to 11 and that could light up, and option is equal to 12, that could light up 12. But today we are not going to do this. What we are going to do today, let me see, are we receiving anything? Yeah, we are receiving it. Okay, so today what we are going to do, we are going to respond with a nice web page. We are going to send response, and that response is going to be a web page. Let me create a function void web page, and this is going to accept int connection ID. So this web page will accept one connection ID. So let me make string web page is equal to blank, and let me return it. Okay, we know that we start a web page. Let me copy this. So let me copy this. Web page plus is equal to is concatenation. Whatever is in web page, let it be there, plus add something else to this web page. So I will most probably 1 2 3 4. So let me open. So we know that we start an HTML document with HTML and we end an HTML document with HTML. We know that HTML document has head and it has head closing, and inside the head it has title tag, and let us say ESP. Alright, so let me call it ESP and close the title tag. We still have some limitations of sending the length, right? So it depends on the length of the web page you want to send, but yeah, limitations are always there. So now we have head, and after head, if you know your HTML, right, we have body, right? So an HTML starts with an HTML page because we are doing concatenation, right, and ends with an HTML page, and then we have title, we have body, and inside the body, okay, let me have h3 tag, and let me have h3 and say welcome to home automation. So I'll say welcome to home automation, right? And let us do one thing right here. Okay, so let us try this first, right? Because we have to send two things. Number one, we have to send the response, and as soon as we send the response, we have to send the web page as a response as well. So for that, I will create string response is equal to, you know that response will be 80 plus CIP SEND, right? So 80 plus CIP send is equal to, and I'll say response plus is equal to concatenate few things here with the response. Okay, 1 2 3, maybe, who knows. Response is equal to plus is equal to this connection ID. So I will be supplying the connection ID, right, and I will be supplying comma 80 plus CIP send to this connection IDs. For example, if you have if you have 4 people, first may get 0, second may get 1, third. So it depends who are you going to close connection for. Let's say we have 5 people attached, right? So we are not going to close connection for all if one is turning the LED on or off. So that's why we are using connection ID. Connection ID will be returned by doing ESP.read minus 48, which is going to be 1, 2, 3, 4. It matters, or it depends on the number of users that get connected to our device. We already seen in the previous class. Okay, 80 plus CIP send is equal to connection ID, and we are going to send, as I said, this web page. Right here we are going to send web page dot length, count the entire length of this page and send it as a response so that the response get prepared, right? So, and execute the response. I'll say response plus is equal to the carriage return, and the next line means the execution happens. And now what we are going to do, I am going to call this function right here, right, and I am going to say that I want to send 2 different things right here. First, I want to send response, and to send response I am giving you 1000 milliseconds, which is 1 second, and the debug is going to be debug, right? And here what I am going to send a new web page, and for that I am going to give you 1000 milliseconds, and debug is going to be true or false, right? So let me okay, now let us call this here. I suppose it's done, right? What do you say? Okay, let me try this here. If the request comes, you know that you are sending the response, so there is no other option, right? So let me do this here. So I will say if ESP.find, ESP is attached to pin number 2 and 3, serial communication, pin number 2 and 3, ESP. If ESP finds, if the request is an IPD request, IPD, right? So if it's an IPD request coming from the browser, if you're able to find this kind of request, right, then what you do, let us make a function communicate, COMMU, commu. So let's make a function communicate here. So let me see what we can do in this communicate function. So I will say void void COMMU communicate, right? So let me see what we can do here in the function. Okay, we are calling the function communicate, and here what we are going to do, let me say int connection ID. You know that connection ID is going to be ESP.read, and it returns the ASCII of 0, which is 48. I'll just reduce it, right? And if you are able to do that, fine. So I am going to call, let me call this function webpage right here. And because this function requires, you don't require this communicate function, you can do it directly in the loop as well, right? So you can do it directly in the loop. So it all depends, right? So let me not have this communicate function here, right? So let me do it directly in the loop. So I will say, okay, let me just get rid of this communicate function. We'll take it at the end so that you understand first. So if you are able to find, if there's an IPD request, what you do, you go and find your connection ID, right? Okay, and after finding the connection ID, what you got to do is send the same connection ID, right? So it's here, int connection ID, that you are going to send back to the web page function. Yeah, that we can do here, right? So that is, let us do one thing here. Let's call the function web page, right? And we will send the same connection ID, because web page requires connection ID. That's why we have to call this web page function in the loop. Now we are sending connection ID back to the function. This is going to happen only if you are having that IPD request coming, right? So let me upload it and see what response are we going to get. We should get welcome to home automation. Done uploading. So let me see my LED blinking. So it starts blinking. Fine. Blinking. It gets connected with a single blink, right? Okay, now the LED has turned on. I will go to my 192.168.137.43, and you can see welcome to home automation, quick response, right? Welcome to home automation. So now we have got welcome to home automation. Now what we are going to do right here, okay, let's go back to this web page and go inside the body. Alright, so I'll say web page is equivalent to something like this. Right, so let me open a form, and form has two properties, form action and method. Form action is going to be the self action, I don't want to go anywhere, but method is going to be get, right? So form, if you want to skip the special meaning of this character, you can do it like this, so it skips the special, or you can use single quotes as well, so it's not necessary. You can use single quotes as well. And the second thing is going to be I close down my form, right? So after closing the form, let me add few more things here to my web page. So let me just expand it. Right, so let me add few more things to web page. And let me call LED. We have 3 LEDs attached. Okay, LED. So far we are having 3 LEDs, and input type, let's create a button, is equivalent to submit. We have to use input type submit because we are using HTML form here, so we'll be using input type submit. So whenever it's going to be an event handler, whenever you click this button, something is going to happen, and that something is that I want to give it a name. Name is option, right? So name is going to be appended at the end of the URL, because we are using get here, so it is going to be appended at the end of the URL. That means URL will look like this, option, and then automatically is equivalent to is going to come, and the value. So let me give it a value. LED value is equivalent to the first LED, which is 11, right? So that's fine. So let me copy, paste. So LED number 11, LED number 12, and LED number 13. Now why is it like this? Why did I name all 3 options? Because option is going to be the get parameter that we are going to look after, right? So we'll be looking, and we'll say something like that, esp.find option, right? So option. So all 3 times we are going to find only option, but every time we submit the button, the option may have a different value, 11, 12, and 13. So let me see that practically. Since we are connected, you don't need to now open the serial monitor to get connected. You can directly go and see this. And you can see LED 1, LED 12, and LED 13. We have all 3 LEDs now being set up. Okay, let me do one more thing right here. Let me hit a BR, a break line here, a break line here, and a break line here, so that all 3 come in a different lines. Okay. Alright, done uploading. Let me wait unless I have that Wi-Fi LED turned on. Now it's blinking. Blink has stopped and it has turned on. Okay. No, it has not. No, it has. Let me see now again. Yeah, you're getting LED, LED 1, and LED 2. Let me give few more space. It doesn't look nice this way. Let me say 2, 2, and 2. Okay, let me upload it and check again. And by the time it gets uploaded and server starts, so let me have another button here for reload. Reload means I want to check the current status. We'll be creating a different function to check what is the current status of the LED, whether it's glowing, because we want to know, are we turning off or are we turning on. For that I will use a reload function, or I'll create an ahref, and I'll just give slash in here because I want to refresh and reload. So I'll see reload, and I will close the anchor tag here. So let me see this first after hitting, yeah, LED 1, LED 2, and LED 3. And why is this home automation coming after this? I want this home automation to load up front. Okay, let me upload it. Right, so far we have been able to do things right here and do them very correctly. Okay, the third thing that I'll be doing to check the current status of an LED, so I will say plus, so let me concatenate it here before hitting the BR button. Alright, so let me close it down and let me hit plus plus, and what I'll do right here, I will say convert it to string, what, digital read. Alright, so digital read pin number 11 is here, so I'm going to read pin number 11. Alright, so digital read pin number 11, and if pin number 11 returns true, right, you go and print on, and if it returns false, you go and print off, because digital read is going to return 0 or 1. If the LED is on, number 11, you are going to get true, right? So you'll get on. If it's 0, you are going to get false. So you are returning and converting to string and displaying off, right? So either on or you are going to display off right here. So I suppose it is done. So let me copy this right here. So copy, paste, and let me upload it. and we should be able to see the current status of all three LEDs. If we do not have any error, if we do not get any error, we should be able to see that. Now let me hit enter. No, we are not still connected, so let us wait unless we are connected to the device. You should wait. You should not try and hit enter unless you're connected to Wi-Fi. Imagine you're connecting to a third-party router, or maybe you're making your own mobile as a hotspot. So unless you're not connected, so there's no fun. Now you can see this here. All three are off, right? So this is off, this is off, and this is off. So that's very good. So far we are doing it nicely without any errors. So it's very good. Let me give on and off a bit of space. Right, so if it is on, it is on. If it is off, it is off. So let me upload and start doing the rest of the things. Right? So now we know if there's an IPD request. When do you find IPD request? The moment you hit enter, right? The moment you try and load the web page or this IP address right here, so that IPD request is generated and your loop finds the IPD request, and then you are taking the connection 01. It depends on number of people coming. It can either be, for my case, it can either be 0 or 1. But if there are many multiple clients coming, so it can be 1, 2, 3, 4, 5. So everyone will have its own connection ID, and we are going to close connection with every single individual device that is connected to our ESP8266, right? Okay, now after calling the web page, what we are going to do here, now I will say, it's very interesting. We already done it, but instead of reading it like integer, I'll read it in some other way today. Alright, so I will say now what I want to do is, if ESP.find, only if you are able to move the cursor. Now the moment I hit this, let me refresh and reload it. Now you can see it here, 11, 12. Okay, let me reload it again. Fine, so let me go and see what is happening. Yeah, close the connection, and yeah, there's no problem. So the moment, I don't know why are we getting this. Okay, let me try again. Yeah, fine. So the moment I hit 11, you can see I get option is equivalent to 11 after the question mark, right? Because the form method is get. I repeat, the form method is get. I hit 12, so I should get 12 right here. I hit 11, I should get 11 here. So let me copy this. I will say the moment you are able to find, right, if you're moving your cursor to option is equivalent to, now you're moving the cursor to option is equivalent to, that's only going to happen when you have that get working, right? So it means, in some other words, if I use some other words, so this means if the request that is being made from the browser is that of the get request. Why? Because we know that we are going to have option. Option can differ. It can either be 12, it can either be 13, or it can be 11, 1, 2, 3, 4, whatever. But option, the question remains same, the answer may differ. I repeat, the question remains same, the answer may differ. So I am moving my cursor from IPD to here. Now you can see the cursor blinking here, right here. So now the cursor is here after is equivalent to, no, sorry, because I have even typed is equivalent to. So now the cursor is after is equivalent to and is blinking there. So now if you are able to find it, option is equivalent to, what you got to do is, let me create a string MSG. So I'm creating string message, and this time I'll be doing something different. I'll say MSG is equivalent to ESP.read string, right? So until, right, so read string basically until, read all the string until you reach the blank spot, right? So read string until, read all the string, right, after you find, right, after you find option, you take cursor here, right, and you read all the string. In our case, the string is this, and then you find the blank spot. So you're going to read till here, right? So that is why this time I'm not using ESP.read, I'm using ESP.read string until we reach this spot of time, right? And now what you are going to do, I will declare another variable. I will say string command is equivalent to MSG, and let me do serial dot print of MSG. So let's see what are we going to get. and what message are we getting back, right? So let me wait and upload it. It's going to be very interesting today. So some of the lag is going to be controlled also. We're going to control many different things, right? So let us see. Wi-Fi disconnected, LED is blinking, still blinking, blinking has stopped, IP address is returned, and the server is ready. Now let me clear whatever we have got so far, and let me send this option is equal to 11 request. Now you can see that you are getting right here. Okay, you can see that you are getting 11 option is equal to 11, and every single thing that you can see right here from the host 192.168.137. Okay, we have not closed the connection yet. That's why it is like this. So we need to close the connection, right? Because we forgot to close the connection, right? You remember the previous class, right? Because you have to close the connection, right? Every time you complete a round trip. Round trip means a request comes, you find the IPD request. Thus, as soon as you find the IPD request, you take the connection ID, right? You display the web page, and if the web page is showing any, intentions of executing a get command with a question option, then you execute this. But at the end of the day, whatever you are doing, right, what you want to do is, it doesn't matter what you are doing, you have to close down the connection, right? After, and let me do one thing. Let me display this web page, the web page that I'm displaying here, right? So let me display this. Let me first tools. Let me go to preferences, and let me increase the font size maybe to 20. Yeah, okay, so font size is much clear now, right? And now if everything is executed, right, and if everything goes right, so I'm going to take this web page from here and I'm going to display it here. Now, because this is going to happen only if you find no, this is correct. Just a moment. This correct here, right? After executing this right here, right? So now we know that this piece of code will only run. So let me indent it for you. We know that this piece of code will only run when we have a GET request. I repeat, IPD request comes every time you load your browser and ask for the certain IP address. It is going to take it as an IPD request, taking the connection, right? And it doesn't mean every time there's an IPD request you are able to move your cursor to pointer. No, you'll not be able to find it always. Only when you're trying to turn off or turn on your LED will you find it, right? And in that way you are going to read string until you have blank, and then you're printing the same message and then displaying the web page. Why are you doing this? Because if we have to display, imagine we have to display on or off status, right? After turning off, it's going to display the previous status. That is why I'm going to display web page after everything is done. So if there is no IPD request, we're still displaying the web page. And if there is any option get request, you're either turning on or you're either turning off. So I want the latest status of my LED. So latest status will not come if I display web page before this, right? So that's why I'm displaying it here. Okay, and then after displaying, I forgot to close the connection. You'll not be able to re-request and create a new request unless you close the connection. So I'll say string CLOSE So string close command is equal to, what is the command to close the connection? AT plus CIP close is equal to, and you have to pass the connection ID again, right? Isn't it? Yeah, that is it. You are going to pass the connection ID right here. So I will say plus is equal to the connection ID. Why are we doing this? That we are not going to close everyone's connection. Maybe there are few communications that are happening, so we are going to close the connection with a specific user. Right, so connection is closed, and close command plus is equal to right, and what I'm going to do is carriage return and execute it. And then what we are going to do is nothing. Send commands, call this function send commands and pass close commands. Now what are we doing here? Connection ID is equal to, no, it is close command plus is equal to this, and send commands will take the close command and maybe and not go and take it much. So let me have 500 microseconds and debug, which can either be true or false. And now we are closing also. Now let us see, it should work in a proper manner now. And we should be able to see a nice user interface with the current status of LED, and then we are going to deal with that current status of LED, whether that LED status is true or false, right? So let me go and, okay, let me wait for LED unless LED turns on. So I'm not going to load it. So let me see. Yeah, it turns on. Now we are connected, right? And I am going to see my IPD request and IPD response from here. All right. If you are able to find this, then do this. Otherwise, display the web page and close the connection. So yeah, absolutely all right, right? Okay. Let me execute it again. Okay, now you can see that it has stopped because the connection is successfully closed. Now you can see we are able to successfully close the connection, and we are able to pass the get parameter right here, and it closes, right? You can see the connection gets closed automatically, right? And we are able to pass, and yeah, 12 and now 13, we should be able to pass 13, and yeah, all three are off because we are not changing the status so far. We are done, so that's it. And now what we are going to do is before you can see this serial.print right here. If I turn the debug to false, let me turn debug to false first of all. Okay, upload is done. So after turning debug to off, you will be able to see nothing here unless I make an IPD request. Why? Because only when I make an IPD request, right, will I be able to see the string read. What does ESP.read string util? What does it return? Right. So let me see this. Read string until will return 13. We are passing and we are getting 13. Right. Is that clear? All right. And we are going to return 11 and we are getting 11. All right. Is that clear now? All right. So it's as simple as anything. So now what we are going to do, if there are more than, so we can have 100. All right. So yeah, so we don't have to do anything else. So let's not print it out. All right. So let me say string command is equal to message. That's absolutely right, but I will do int command is equal to message dot to int. So I will convert this message because it returns string. I'm going to convert it to integer, and then I am going to toggle the LED digital, right, and toggle, right. So digital write command is going to be the pin number 1, 2, 3, whatever you supply, and second not. If it is on, turn it off. It's off, turn it on, right. So not is going to return the opposite of what it is. That's what you are going to do opposite of what it is. Like if it's on, turn it off. So I'll supply command again. I have to supply this command, or we can say pin number, right. So pin number, digital write to pin number, read the status of that pin number and do opposite of that. If that's on, turn it on. If that's off, turn it off, right. And this is it. Now we will see from the web interface what happened right here. So pin number is here. Alright, so it requires 2 arguments, digital, right. So we are passing pin number and is not Okay, why are we doing digital right here? We have to do digital read, right? So read the status of this pin, right? Pin number 11. If you're passing 11, you're reading the status of pin number 11. If that is 0, you set it 1. If that is 1, you'll set it 0. So that is going to be the toggle of LED. Okay, so let me upload and wait unless everything is done. Right, so I do not have, because the debug is off, nothing will be displayed over the serial monitor. What we have to look at is our LED that we have attached. So LED will start blinking, and the moment LED lights up completely, indicates that you are now connected to ESP8266, or your ESP8266 device is connected to the internet or any Wi-Fi router, or maybe your mobile's hotspot, who knows. Right, so the moment you're connected, let me hit this reload. Now I can load the current status right here. All three are off, right? Can you see this? All three are off. So now I'll hit 11. Now you can see it has turned on my LED 11 and the status is coming. Even if I reload it 10 times, so I'll see, and you can see in front of you, maybe if you have attached all of them, I have attached, LED number 11 has turned on. Now even if you refresh 10 times, so it's still going to remain the same. The LED status is not going to change. You can see all three are now on. Alright, so I have turned on. Now if I go ahead and see the status here, so on and on. So let me turn 12 off. 12 is off. Alright, and 12 is off. Now why are all three turning on? Maybe I have not changed it, right? Okay, we are reading 11, 11, 11. That's why we are having 12 and 13. Sorry, my mistake. Look what I did. Why? Because you have to read if the current status is on, because we were reading 11. That's why all three were turned on. No problem, so we can reload it again. Wait for LED to light up completely. Do not jump in and try to get connected without your ESP being connected to the Wi-Fi access point, right? So let it be connected to Wi-Fi access point completely, then and only then you'll be able to connect to it. Okay, now it's connected. Let me reload. Okay, after reloading, you can see all three are off. Now I turn only one on, right? Only one is on. I will reload. Right, it doesn't matter you reload 200 times, it's going to remain on. You can see on. Right, I'll take it to some other tab. Let me go to tab number 2 to check the current status of LED. Right, you can still see it's on. Now let us turn all three on. LED 11 is on, LED 12 is on, and LED 13 is also on. So let me connect my mobile phone and turn them off from my mobile phone. Now if I refresh this, you can see all three are on. So let me get connected to my mobile phone, and let me turn it on from my mobile phone. And to get connected to the mobile phone, make sure you're connected to the same network, because it's still happening over Ethernet, right? Over intranet. We have not connected it to internet yet, right? We haven't enabled that MQTT communication, right? So I'll be connected. Yeah, now I'm connected to mobile device, and I will turn off my LED. Now LED 11 turned off. Now you can see if I refresh here, LED 11 should be off, right? Because I have turned it off from my mobile phone. So let me turn off 13 from my mobile phone now. Here I go, hit 13, turn off 13. Now 13 is off. I'll try and refresh, or you can even hit the reload button, one and the same thing, and you will notice that LED number 13 has been turned off. So this is how you have been able to get connected right to ESP8266 with a very nice user-friendly interface. It's still missing many different things, but yeah, we have to make sure that we go slow and steady. But while we are going, we need to understand each and every process, right? That third-party apps, they do not tell you those processes. Right, only you saw that we had that lag. We have tried to control it to some good amount of extent, right? But still there are some problems. We will be rectifying all the problems in the upcoming videos, right? And we will be making sure that we control multiple devices like servos, like anything, like many different things, or we will make sure that we do it with the help of Node.js. We'll integrate AJAX and see that the website is displaying temperature of your room it's displaying alarms, right? It's doing some nice things. So that is, you know, going to be the next video. Inshallah, we will be in touch and we'll be making several videos for you guys. And what you need to do is practice very hard. Unless you have understood the communication and unless you have understood what we have done here, right? It's not easy. That we are doing here is we are communicating. First we are trying to communicate using 2 and 3 pins. We are communicating with our ESP8266 from Arduino, right? And ESP8266 is communicating back to Arduino, right? So that there is going to be a bit of lag, but that lag is going to be controlled, right? So I'll show you how to make it more faster. Today I've shown you how to make 70% faster than what it was earlier, right? You can see that it's happening very fast now. I turn it on, right? So now you can see the light is on. I turn the light number 2 on. Now you can see that light number 2 is off, right? It was on earlier, now it's off, right? So I can turn it on again. Now you can see both the LEDs are off, right? So I can turn the third on, right? So it's happening a bit, not only a bit, it's happening much faster than what we had learned earlier. So I wish you all the best, and do wait for the next video and practice hard, and make sure before you move to the next video, or everything that is in video number 1, 2 and 3 is already done, understood and working, right? Unless you got to take care of yourself, right? Bye bye, take care.